Okay? Just hold your thoughts. Okay? I have a system of equations. What makes it a system is that I have two equations with two variables, x and y. When I solve it, I'm looking for a value of x and a value of y that works for both of my equations. I'm going to solve using substitution, and substitution involves 3 steps. My first step Now, when you are picking your equation, you want to choose one of the equations that has a single variable. And here's what I mean by a single variable. I mean an equation that has an x by itself or a y by itself without a coefficient. So looking at these two equations, do I want the top or the bottom?
Bottom.
The bottom. And here's why I want the bottom. If I take that bottom equation, 3x plus y equals 5, and if I subtract 3x, now are 5 and 3x like terms?
No, so you just, on the other side of the 5.
So it's just 5 minus 3x equals y. But by doing that, I isolated y. If I had chosen, let's say, the top equation, it would be harder to isolate that variable when it's got a number in front of it. A lot of times that means you'll end up with fractions, and we want to avoid those. Also, I subtracted the 3x and not the y. If I subtracted the y, I would have 3x, and I didn't want that. I wanted a single variable. Okay, so that was step 1. Okay, pick one equation and isolate. What's isolate mean? Get it by itself. And isolate one variable. It doesn't matter if you're isolating x or y, you're looking for something that's single already. Okay, so that was my first step. Let's go on to step 2. Step 2. So this is what we have so far. You don't have to rewrite this part. We've got 6x plus 3y equals 12, and we had 3x plus y equals 5, and we took that second equation and we solved for y. So y equals 5 minus 3x. That was all the first step. My second step is to take what we just isolated. We isolated y. So I'm taking what y equals, that chunk, and plug it into the top, into the y spot. Now here's why we're plugging it into the top equation. The system has 2 equations. We already used the bottom one, so when we go back and plug it in, we need to use the other equation. You cannot use the bottom equation and then plug it back into the bottom equation. It would be a circular argument. You wouldn't get anywhere. You need to use both. So if you've already used the bottom, go back to the top, or vice versa. So I'm going to take that top equation, 6x plus 3y equals 12, but I'm going to take out the y, and I'm going to plug in the 5 minus 3x. So 6x plus 3, parentheses, 5 minus 3x, and then equals 12 is still there. Then I'm going to distribute and solve it. Okay, so I've got 6x plus 15 minus 9x equals 12. Very good. I've got like terms on the same side. Negative 3x plus 15 equals 12. Subtract the 15. Negative 3x equals negative 3. Divide by negative 3. X equals 1. Okay, so let me summarize what we did. The first step, we picked one equation with a single variable and we isolated that variable. In step 2, step 2, substitute into the other equation. Don't knock back. Step 2, substitute into the other equation. Remember, we started with the bottom equation, so we plugged it into the top equation. So let me write it out. Step 3, find the missing variable. And I'll do this step in green. Okay? We found x, so that meant we were missing the y. Now, we've got lots of options for substituting that value in and going back and finding our y. What would be the easiest option?
Plug it back into the red.
Plug it back into that red equation, okay? Remember when we said, okay, let's start by isolating y because it was a single variable and we found it? Plug it back in there. So I'm using green. We've got y equals 5 minus 3 times what? Y. Y1. That's what x equals. So 5 minus 3 gives us 2. That's y. Okay, so our solution, we found what x is, we found what y is. There is a way that I want you to write your solution. I'll go back in just a second if you need it. Your solution is always going to be written as an ordered pair, like when you're plotting points on a graph. An ordered pair, x goes first and y goes second. So what was x? What was y? That's our solution. 1, 2. There we go. Okay, what are we doing with that new equation?
You gotta plug in.
Plug it in, yes. If you had negative 3y plus 3, you'll get the same thing. Okay, plug it in where? The bottom in that 2x. Remember, we just found what x equals. We want to plug it into the x spot in the other equation. So we're going to say 2 parentheses. Plug it in. 3 minus 3y. Keep the rest. Minus 4y equals 6. And most of you did this fine. Here's where the mistake started. Distribute, so we get 6 minus 6y minus 4y equals 6. Combine like terms. Now, those terms are on the same side of the equation. Don't add 6y over or add 4y over. They're sitting right next to each other. Just squeeze them together. What's negative 6y minus 4y? So 6 minus 10y equals 6. From here, what do we do? Subtract 6. This was the other big mistake I saw. We get a 0. That's okay. Listen, 0 is not nothing. 0 does not mean the equals is gone. 0 does not mean you're stuck. 0 does not mean you're done. 0 is just a number. So when we subtracted the 6 and we got 0, that's okay. What do we do from there? Divide by -10. And y equals 0. Is that enough?
No, then you gotta plug it back in.
Plug it back in where? Go. To that isolated equation. So let's say x equals 3 minus 3 times 0. And I saw some mistakes here. What's 3 times 0? What's 3 minus 0?
3.
3.
So it's 0, 3. No, 3, 0.
So the solution is 3, 0. Why does the 3 come first? Because that's x.
But really, couldn't you have plugged that back into the original equation?
Yes, you could have. Okay? If I took that y equals 0 and I plugged it back in, let me pick another color here. If I took y equals 0 and I plugged it back into the original equation,
That's what I did.
I would get the same thing. Okay? I would get the same thing if I plugged it into the bottom equation. Again, it's just choosing what's going to be the easiest for you to work with. Yes? Okay, so that was our first step, isolating a variable. What are we going to do with that? Plug it into the x where? In the top. Okay, we're going to go back to that top equation and we're going to substitute into x because we isolated x. So we're going to say 3 times -4 plus 3y plus 4y equals 1. We've got to keep the rest of that top equation. -12 plus 9y plus 4y equals 1. We've got some like terms. Add the 12. So 13y equals 13. Then what? Divide and y equals. What do you do with y equals 1? Plug it back in. Now guys, you really can plug it back into any equation. I'm going to choose the one in purple just because it's got x isolated already. So x equals -4 plus 3 times 1, which gives me -4 plus 3, which is -1. That's x. So the solution is what? -1, 1.